Okay, so this section is on trigonometric ratios. You probably want to pause your video here and copy down these three trig ratios that we're looking at. And then we'll explain what each one of them is. So the first one is sine from angle A. And so the way that we write sine of angle A is we will write sin A. Right, that's how I know I'm looking at sine of A. So because I'm at angle A, I'm going to be here in this corner. That's angle A, that's where I'm at. It tells me sine of A is the length of the leg opposite A over the length of the hypotenuse. So we can see if I'm here at angle A, across from A, this is the leg that's opposite angle A. And then we know the hypotenuse of a right triangle is going to be the one opposite the right angle, right, the longest side. So we always can identify the longest side. And so my other two sides, again, we've got opposite A, and then the one that's right beside A, that's not the hypotenuse, we call that adjacent. So you can see sine is the opposite over hypotenuse. That's what I remember it as. Okay, so the way that I remember this, I know that sine of any angle is always the opposite over the hypotenuse. Okay, the next trig function we're going to look at is cosine from angle A. So again, I'm still at angle A. Cosine of any angle is going to be our adjacent side over the hypotenuse. So again, in this particular case, when I'm looking for cosine of A, cosine is going to be the adjacent leg, which is going to be leg AC over the hypotenuse, which is AB. And then the last trig function that we're going to be looking at is tangent. Tangent from any angle is always the opposite side divided by the adjacent side. So again, if I'm looking from angle A, if I'm taking tangent of A, my opposite leg is segment BC. My adjacent leg is segment AC. So tangent of A would be BC over AC in this example. So this is very arbitrary. It's kind of hard to understand with all of these segment lengths instead of actually numbers. So let's do a couple problems with numbers, and maybe that'll make it a little more clear. So here we're going to be looking at this triangle GHF, and it wants me to find sine, cosine, and tangent, but it tells me what angle I'm going to be doing that from. I want to find it from angle H. So I'm going to be looking for tangent of H. I'm going to be looking for sine of H, and I'm going to be looking for cosine of H. So because all of these are from angle H, that is my reference point. That's my starting point, is at the vertex H here that I've labeled with a yellow dot. So from this point, let's do sine first. So if you need to look back at your notes, you can. Sine is the opposite leg, which is 12, because 12 is opposite H, over the hypotenuse, which in this problem is 15. So we could say sine of H would be 12 over 15, and then we can reduce that fraction. 12 over 15 reduces to 4/5. Next, cosine of angle H. So cosine is going to be the adjacent side over the hypotenuse. So from H, my adjacent side is 9. My hypotenuse is still 15. So this is going to be 9 over 15, which we can reduce to be 3/5. And then my last trig function is tangent from angle H. It tells me here tangent is the opposite over the adjacent. So again, if I'm from angle H, the opposite side is 12, the adjacent side is 9. So tangent of h would be 12 over 9, which we can reduce to be 4 over 3. Okay, here I want you guys to try this example. So I've got the same setup that I had before, except this time what's different? Now it's asking me to find sine, cosine, tangent, but this time our starting point is angle F. So in the previous example, we were at angle H. Now then, I want you to do the same, but from angle F. So pause the video, try it on your own. Okay, so if I was asked to find sine from angle F, we have to know sine is the opposite over the hypotenuse. So from F, my opposite side is 9. My hypotenuse is 15. So sine of F would be 9 over 15, which we can reduce to be 3/5. Next, if I was looking for cosine from angle F. So again, here's my reference point, angle F. Cosine is a ratio of the adjacent side over the hypotenuse. My adjacent side here would be 12. My hypotenuse is 15. So cosine of F would be 12 over 15, which reduces to 4/5. And lastly, tangent from angle F. Tangent is the opposite over the adjacent. So my opposite side is 9. My adjacent is 12. So tangent would be 9 over 12, which reduces to 3 over 4. Okay, so here it asks me to find sine, cosine, and tangent ratios for 30 degrees, for 45 degrees, and for 60 degrees. So on Thursday, you should have learned about two special right triangles, which are a 30, 60, 90 special right triangle and a 45, 45, 90 special right triangle. Okay, so I know you just learned them, but you're going to have these triangles memorized for this section. So for a 30, 60, 90, across from the 30 is a side of 1. Across from the 60 is a radical 3. And then the hypotenuse is a value of 2 for my 30, 60, 90. And then for a 45, 45, 90, across from the 45s, I have a value of radical 2. And then my hypotenuse is still a value of 2. Okay, so now if they ask me to find sine of 30, cosine of 30, and tangent of 30, that means I'm going to go to the 30-degree angle, which is here. Sine is the opposite over the hypotenuse. So that's going to be 1 over 2. Cosine of 30, that would be the adjacent over the hypotenuse. So that's going to be radical 3 over 2. And tangent of 30 is the opposite over the adjacent, which is going to be 1 over radical 3. Now next, let's do sine, cosine, and tangent of 60 degrees. So I've got sine of 60, cosine of 60, and tangent of 60. So I'm looking at the same 30, 60, 90 special right triangle, but now my reference point is not the 30-degree angle, but the 60-degree angle. So I'm going to be up here at the 60. So if sine is the opposite over the hypotenuse, opposite 60 is radical 3. The hypotenuse is 2. So sine of 60 would be radical 3 over 2. Cosine of 60, again, I'm here. My adjacent side is 1. My hypotenuse is 2. So that's a value of 1/2. And then tangent of 60, that's my opposite, radical 3, over my hypotenuse, 2. So that's going to give me a value of radical 3 over 2. And then the last ones, let's do our 45-degree angle. So sine of 45, cosine of 45, and tangent of 45. So this one's a little bit stranger because what's my reference angle? This time it's a 45-degree angle. Well, in a 45, 45, 90 special right triangle, I could choose either angle as my reference angle because they both are 45. And it won't matter. You'll get the same answers either way. So I circled the 45 I'm looking at. Sine would be the opposite. Radical 2 over the hypotenuse 2. So that's going to be radical 2 over 2. Cosine from this angle would be my adjacent over hypotenuse. Adjacent side is also radical 2 over the hypotenuse 2. And then tangent would be the opposite side, radical 2, over the adjacent side, radical 2. And now if I divide a radical 2 by a radical 2, I just get a value of 1. Right? Because what is 3 divided by 3? 1. What's 11 divided by 11? 1. Whenever I divide something by itself, I always get a value of 1. So this problem here will be something similar to what you were doing in the last section, where we've got a 30, 60, 90 special right triangle, and we're missing one of the sides. They're missing y. So if I know the 60-degree angle, and opposite it is a side of 9, and then I know what a 30, 60, 90 triangle is supposed to look like. I know that across from the 60 is supposed to be radical 3, and then I know the hypotenuse is supposed to be 2. So then I know across from the 30 is supposed to be a 1. So how did I get from how did I get from a radical 3, which is what I know it's supposed to be, to a value of 9? Well, I had to have multiplied by something. That means radical 3 times something, let's call that something x, has to be equal to 9. Okay, then when I solve this, I get 9 divided by radical 3. When I divide by radical 3 on both sides. And so that means the number that I multiplied by here would be 3 radical 3 when I simplify that. So that means in order to find y, I need to multiply by that same number, by that 3 radical 3, what it used to be, which was a 2. So if I do 2 times 3 radical 3, I'll get a value of 6 radical 3. Okay, so one of the things here that we need to know is if I take sine of some value x, that's equal to cosine of 90 degrees minus that same x. And this goes in the other direction as well. If I have cosine of some angle x, I can rewrite that as sine of 90 minus x. So that's the formulas we're going to have to use in order to work B part here. B part says, if I had cosine of 70, what's something else I could rewrite that with as sine? Okay, well, cosine of 70 degrees, that's going to be equal to, using this formula, it's going to be equal to sine of 90 minus 70, which means it's going to be sine of 20 degrees, right? Because 90 minus 70 is 20. And then the second part, if I had sine of 34. Okay, so I'm going to use the top formula. If I have sine of 34 degrees, that's going to be equal to cosine of 90 minus 34, which is going to give me a value of cosine of 56. Okay, here on this problem, we have a plane taking off and climbs at a 12-degree angle. So you see they have that drawn for me here. Plane takes off at a 12-degree angle. Is that angle sufficient enough to fly over an 11,088-foot mountain that is 12.5 miles from the runway, or does the plane need to increase its angle of ascent? So the first big problem here is that I have two different values that I'm working with. We can see here the distance away is 12.5 miles. And then we're wanting to know, is it going to get taller than 11,088 feet? So I know at some point I'm going to have to do a conversion. But when I first start working this problem, let's just keep everything in miles. It's going to be smaller numbers. It's going to be a little bit easier to work with. So I'm wanting to know how high the plane will be, so I'm looking for this value x, given all this other information. So when I look at the known angle that I have, that's a 12-degree angle, what are the two sides that they give me here in relationship to 12? Well, the x is opposite the 12, so I'm dealing with the opposite side. And the 12.5 miles, that's not the hypotenuse, so that must be the adjacent side to my angle 12 degrees. So if I'm dealing with opposite and adjacent, I need to look back. Which trig function has both opposite and adjacent in it? And that would be tangent. So when I'm dealing with tangent, I can say tangent of the angle. Okay, what's the angle this time? It would be this angle, which is 12 degrees. So tangent of 12 is equal to the opposite side, which is the unknown x, over the adjacent side, which is 12.5. So now this setup's a little bit different than the ones we've had so far. Now I'm going to be looking for x, and x is stuck inside a fraction. So how can I get x out of the fraction? Well, I'm going to write it as a proportion and cross multiply. 1 times x is equal to x, and then I have 12.5 times tangent of 12. And so you're going to have to put this in your calculator. You got to put in 12.5 times tangent of 12, and make sure your calculator is in degrees. So you can go through the settings and click degrees to make sure you are in degrees. When you do this multiplication, you're going to get about 2.66. And so what does that mean? It means that the height that the plane is going to be is about 2.66, and again, we're talking about miles. So now what I need to know is 2.66 miles enough to get over an 11,088 foot mountain? So what we would do is we would take our 2.66 miles and multiply by how many feet are in a mile. That would be 5,280 feet. So 2.66 times 5,280. Let's do that. Give me just a second. 2.66. So that means the plane is approximately 14,044.8 feet in the air. Well, is that high enough to get over an 11,000 foot mountain? It is, because the number is bigger than 11,000. Okay, and here's our last different kind of problem for this section. Now then, instead of knowing the angle measures, all I know is a couple of the sides. And then it's wanting me to find what those angle measures are. So what's the measure of angle A and the measure of angle B? So let's start by looking for angle A. Well, angle A is up here. Now from angle A, what are my two known sides? Well, the 4 is the hypotenuse, so I know the hypotenuse. And the 1, is that adjacent or is that opposite? Okay, well, opposite would be CB, so it's not opposite. So that means the 1 here would have to be my adjacent side. So because I know the hypotenuse and the adjacent side, I need to know which trig function to use. Well, cosine is the one that deals with adjacent and hypotenuse. So I could say cosine of the angle A is equal to the adjacent side, 1 over the hypotenuse, 4. So now I have the trig function set up. Now in order to solve for A, here's the new part. Right now I can't get A by itself because I'm taking cosine of A. A is stuck inside of that cosine. So how can I undo a cosine? Well, a lot of people's first answer is to say you divide, because it does look like it's being multiplied, but that's not what's happening. This is not cosine times A. This is cosine of A. So in order to get rid of this cosine on the same side as A, we're going to use what's called an inverse cosine, or sometimes called an arc cosine. And what that does is it undoes a cosine. on both sides. So it looks like cosine to the negative first power, but we call it an inverse cosine. So now inverse cosine of cosine gives me a value of a. Then on the right side, I have to take the inverse cosine of 1/4. And so you'd have to put this in your calculator. The way that you get inverse cosine put in is you're going to have to click your shift button or your second button, and then you should see, like where there's normally cosine, you should see that little cosine to the negative first for an inverse cosine. So I'm going to put in the inverse cosine of 1/4, and when I did that, I found that angle A has to be 75.5 degrees, and I rounded that to 1 decimal place. Okay, now the second part of this question, it tells me to do the same thing, but this time find the measure of angle B. So now I'm looking for this angle that I'm coloring here in blue. So now from angle B, what are my two known sides? Well, 4 is still the hypotenuse, but this time 1 is my opposite side from angle B. So for B, I'm dealing with the opposite and the hypotenuse. So you may need to look still, but you've got to start memorizing this. Which trig function is dealing with opposite and hypotenuse? That would be sine. So we could say sine of the angle, which is B, is equal to the opposite over the hypotenuse. And now to solve for B, it's very similar to the last problem. This time, B is not by itself because it's being taken sine of B, or we are taking sine of B. So to undo that, I'm going to do an inverse sine on both sides. The inverse sine of sine cancels and leaves me with B. And then in my calculator, I'm going to put in the inverse sine of 1/4. If you do that, you should get a value of 14.5 degrees. And again, I'll round it. Okay, so you tried these two, very similar to what we just got done doing. So pause the video and see if you can work these two out. We're looking for the measure of angle P and the measure of angle Q. So first, if I'm looking for angle P, that's down here, what two sides do I have in relationship to P? Well, 2 is the opposite side, and 3, that's not the hypotenuse, so that must be my adjacent side. So I'm looking for which trig function deals with opposite and adjacent. That would be tangent. So I could say tangent of angle P is equal to the opposite over the adjacent. That would be 2/3. And now to solve for P, I'm going to take an inverse tangent of both sides. And so now I'm going to get P equals the inverse tangent of 2/3 is going to give you about 33.7 degrees if you put that in your calculator. Now for the second part, same things, or same numbers, same triangle, except now we're looking for angle Q. So now what are the two sides given to me in relationship to Q? Well, I have the opposite side, which is 3, and I have the adjacent side, which is 2. And so which trig function deals with an opposite and an adjacent? That is still the tangent function. So we could say tangent of our angle Q is equal to the opposite side 3 over the adjacent side 2. To get Q by itself, I have to take an inverse tangent of both sides. And so that's going to give me Q equals, and then in your calculator, inverse tangent of 3/2 is going to be 56.3, round to 1 decimal place, 56.3 degrees.